We will be looking at the packet titled Objective 3 Assessment. I'm going to do some of the problems, and I will ask that you try some of the other ones. The first problem is number 1. Well, anytime I'm doing a word problem, I begin by reading the question sentence. That is the last part of the statement that specifically asks us what we'll be doing. Here the question sentence says, which statement best describes the relationship between the two lines when they are graphed on the same coordinate grid? Okay, so we have one line that's already graphed, and we're going to graph a second one, and we're going to compare the two. All right. It says if the y-intercept is changed, the y-intercept is changed to 0, 5. Well, currently the y-intercept appears to be at 0, 6. So 0, 5 would place the new y-intercept here. 0, 5. So that's a shift down 1 unit. And the slope becomes negative 4. Well, slope. We've discussed already that slope has a number of meanings for us. One term, or one way we think about slope, we use the letter M to designate slope, is rise over run. Okay, so when we say the slope is negative 4, we can take this negative 4 and write it like a fraction by calling it negative 4 over 1. So in this case, this negative 4 is the rise. Since it's negative 4, it will be down 4 units. 1 is the run. That's to the right. So from the point that we have here, we will go 1 right and 4 down. 1 right, 1, 2, 3, 4 down here. 1 right, 1, 2, 3, 4 down. 1 to the right, 1, 2, 3, 4 down. And now we see we have this new line. And these two lines, they're pretty close to each other, unfortunately, in this picture. Okay. You can see the original black line is slightly steeper. If you were on your bicycle or skateboard, you'd be going a little bit faster down that black line. The blue line is slightly less steep. The y-intercepts, the original line has a y-intercept of 6. The new one has a y-intercept of 5. Okay, so now we should be able to compare them. The y-intercepts are 1 unit apart. That's true. But the lines are parallel. No, these lines definitely intersect each other. F is no good. The y-intercepts are 1 unit apart. True. And the lines intersect at 1, 1. 1, 1. That appears as that may be correct. It does look like, I'm going to put a question mark out beside G. Potentially correct. The y-intercepts are 1 unit apart and the lines are perpendicular. Well, what does this term mean? Perpendicular means intersects to form a right angle. Two lines are perpendicular when they form this sort of relationship here. Like a T, they form a right angle. Clearly, these two lines are not perpendicular. H is no good. The y-intercepts are 1 unit apart, correct. And the lines intersect at 1, 0. 1, 0, they did not appear to intersect. Number 1, the correct answer is G. Okay, number 2. I'm going to leave number 2 to do on your own. I believe you will be successful on number 2. It's a proportion problem. You could set up a proportion and cross multiply, or you could simply do a division and then a multiplication. Next, number 3. What is the slope of a line that contains the coordinate points 8, negative 3, and negative 2, 7? Well, recently we've learned the slope formula. M equals change in y divided by change in x. That is, we should subtract the y coordinates and divide it by subtracting the x coordinates. We can also look at the rise over the run. We'll do both of those in this case here. Let's begin by plotting these 2 points. 8, negative 3. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3. That is the point 8, negative 3. Other point, negative 2, 7. Negative 1, 2 to the left, 7. 1, 2, 3, 4, 5, 6, 7. Alright, that is the point negative 2, 7. Using our straight edge and drawing a line through those 2 points. Okay. As you can see, the line is falling from left to right. This indicates our slope will be negative. Negative slope. Line moves downward. In this case, that's no particular help because as we see, all of these are negative numbers. Okay, so let's employ our slope formula. The slope formula says, subtract the y's on top, subtract the x's on bottom. Well, our y values, that's the second in each ordered pair. One y value is 7. The other y value is negative 3. I'm going to subtract 7 minus negative 3. In the numerator, 7 minus negative 3. Since I did 7 minus negative 3 in the numerator, I must subtract negative 2 minus 8 in the denominator. Negative 2 minus 8. All right. Using our calculator, negative 7 minus negative 3 is a positive 10. Subtracting a negative is like adding. Negative 2 minus 8 is a negative 10. So we have 10 over negative 10. Using the calculator to reduce, 10 divided negative 10 is a negative 1. So that is the slope, negative 1. We see the correct answer in this case is A. Now let's use the rise over run method. All right. Well, all you have to do is draw a right triangle between any 2 points. And in this case, there's a lot of points you could draw between, but I'm going to use the original points that we graphed. I'm going to go over and down. Now I will count the rise and the run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down, since it's down negative 10. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To the right. So our rise is negative 10. Our run is 10. Again, negative 10 over 10 is still the same negative 1. So we see the slope is negative 1. Another way to think of negative 1 is writing it as negative 1 over 1. This is the run to the right. This is the rise, in this case, down since it's negative. We will go 1 to the right and 1 down. From this point, 1 right, 1 down, 1 right, 1 down, 1 right, 1 down, 1 right, 1 down. You can see graphically what it means to be a slope of negative 1. For every 1 unit we go to the right, we go 1 unit down. All right, problem number 4. The cost, first get to the question sentence. What does the cost per mile driven represent? Well, let's go back to our slope-intercept form. Y equals mx plus b. We know m is the slope. And slope is a rate of change. Okay. B is the y-intercept. It's a point. All right. It is the value where x is equal to 0. Y-intercept is the point 0, comma b, this constant. All right. So we want to know what's the cost per mile driven. Well, this word per is key. Per is a rate word. Okay. Indicates rate. Right there, I'm inclined to think that we're dealing with the slope. Okay, but let's see if we can potentially write equations for each one. The cost of renting a car for one day at Cars Plus is $20 plus 10 cents per mile driven. The cost of renting a car for one day at Need a Car is $20 plus 15 cents per mile driven. In a graph of cost of car rental, what does the cost per mile driven represent? Well, I'm going to write an equation for this place here. Car Plus. Okay. Their cost is $20 plus 10 cents per mile. So I'm going to let C be my cost. C is the cost. Okay. And I'm going to let M be my miles driven. Okay. All right, so it says the cost is $20 plus 10 cents per mile driven. So I would take that 10 cents and multiply it by however many miles, 0.10 m. So here you would see our cost function. To find the cost, we would simply take the number of miles and multiply by 10 cents and then add that $20 flat fee. Well, now hopefully you can see what the slope and y-intercept are. This here is the slope. We say slope is the coefficient of x. In this case, the input variable, the x variable, is m, the miles driven. The output, the y, is the cost. This is my slope. This is the y-intercept. It's the constant. As you can see, that's the cost whenever no miles are driven. That's the start amount. This 20 is the point, 0.20. When the number of miles is 0, the cost will indeed be $20. Okay, so we see in this situation, the cost per miles driven, this 0.1, is indeed the slope. Number 4, the answer is C. All right. Number 5. Number 5 says, which table identifies points on the line defined by the equation y equals negative 5x minus 9? Well, this is an excellent one to employ solving for y. We have y minus 5x equals negative 9. So now, solving for y, I will add 5x to both sides. That leaves me with y on the left and 5x minus 9 on the right. Now I can simply take some of these x values and substitute them in and see what the corresponding y values are. Here I go to make my own table. One point that I see is very useful is 1. Here it says 1 goes to negative 9. Here it says 1 goes to negative 14. Here it says 1 goes to negative 4. So if I can just evaluate where 1 goes to, that may indeed answer this question. All right, so let's substitute 1, x, y. When x is 1, my question is what is y? Here I go into my equation. Y equals 5. Instead of x, let's substitute 1 minus 9. y equals 5 times 1 is 5 minus 9 is negative 4. What we have found is when x is 1, y is negative 4. So clearly that eliminates A. 1 does not pair with negative 9. That eliminates B. C is a possibility. 1, negative 4. So we're down to either C or D. All right, looking at the D table, 0 pairs with 9. This point is an intercept. It has a 0 involved. It is the y-intercept. Y-intercept. Well, look back at our equation. Again, our equation is y equals 5x minus 9. We know this is the slope, and this is the y-intercept, negative 9. So indeed, it cannot be D either. It must be C. Let's investigate a couple of more points to verify that. We have I want to check what 3 goes to and what 6 goes to. 3 and 6. Okay, back to our equation. We have y equals 5x minus 9. Let's substitute 3 in place of x. Y equals 5 times 3 minus 9. Well, 5 times 3 is 15. 15 minus 9, 6. So, when x is 3, y is 6. 3 pairs with 6. Just exactly like it says in this table. Now let's verify 6. What does it go to? Y equals 5x minus 9. Substituting 6 in place of x. Y equals 5 times 6 minus 9. 5 times 6 is 30. 30 minus 9 is 21. When x is 6, y is 21. We see here 6 goes to 21. So indeed, C is correct. 1 through 5 is all I'm going to complete on this video. We'll make another video to examine 6 through 10.